Next, I'd like to talk about influential observation. So an observation is influential for a statistical calculation if removing it would markedly change the result of a calculation. So for example, I'm talking about outliers, right? Outliers affect the calculation of the mean, right? So it's an influential observation. So the result of a statistical calculation may be of little practical use if it depends strongly on a few influential observations. If there are a lot of outliers, it skews things for everyone, right? There's a big difference between using mean income versus median income to describe the income in the United States. You want to use median because it's not affected by outliers like Elon Musk, Jeff Bezos, things like that. So points that are outliers, either in like our x, which is our explanatory, versus y, which is our response, direction of our scatter plot, are often influential for our correlation. And points that are outliers in the x direction are often influential for our least squares regression line. So we need to be careful about that. So let's look at this first very simple example to talk about the effects of outliers. Okay, so here is a completely made up data set. So for this data set, I have calculated a correlation coefficient to be R is 0.880. So what type of correlation is this? Well, this is definitely like strong correlation, right? I want something above a 0.8. It's strong, it's positive, that's a good thing. But the problem begins when I cover up this data point right here. Like pretend that's not there. I don't have a white marker, so you're just gonna have to deal with this. But like pretend, let me try that again. Pretend it's not there. So ignoring that data point right there, do we now see that what type of correlation do I have just in this little box here? Do I have no correlation? Do I have positive correlation? Do I have negative correlation, right? It's kind of hard for us to visualize. So this outlier was what was really making this data set have strong positive correlation. So how does that affect my lines of best fit? I'm so glad you asked. So looking at this next example, right? So here we have physical activity and weight loss, right? Here's our data set, right? We have our explanatory variable, our response variable, right? So here we have including all of our data, including this subject too. This is quite the outlier, right? It's really far away from our line of best fit. If I include subject 2, right, my data, my R value has positive weak correlation, but if I remove subject 2, we've got negative correlation, right? This kind of makes it look like if you lose energy, you're gaining weight because if you work out more, you're gaining weight because there was such an outlier like subject 2. Another thing we need to do is really consider how data are grouped. So let's look at this next example. So let's consider how data are grouped. So correlations can be misinterpreted when data are grouped inappropriately. Grouping data has been known to hide correlations. So let's consider this hypothetical study, meaning i.e. I made up this data, in which researchers seek a correlation between the hours of TV watched per week and a high school grade point average. So they collect 21 data pairs in this table right here. And I know we're already thinking like, oh yeah, there's going to be a negative correlation because the more TV you watch, the lower your GPA is going to be. That would make no sense. And I think this would be like pretty strong, right? But let's make a scatter diagram of this data. And it shows there's like virtually no correlation. Well, what do you mean? Like if I watch 25 hours of TV, it has no effect on my GPA, right? So looking at this data, we would have to conclude like the amount of TV you watch has no effect on your GPA. So just let your kids watch, like all the TV. Well, there's a problem. It depends on what these students were watching. So we realized, one imaginary researcher realized that some of the students watched mostly like educational programs, like Bill Nye, National Geographic type moment. That was me. While others tend to watch comedies, dramas, and movies, i.e., that's my sister. She's a musical theater major. But this like really affected GPA. So we're going to divide the data up into two groups. One for students who watch mostly educational programs, group one, and one for others who watch just like regular TV, like Survivor. Is that still a show? So let me show you what these scatter plots look like once we divide up this data. Boom. We've got different types of correlations. Now, before it looked like there was no correlation. Now for group one, this is the like nerdy TV folks. And this is the like regular TV folks, right? We've got a positive correlation. So for students who watched educational TV, it had a positive effect on their GPA. And for students who watched not educational TV, right, it had a negative effect on their GPA. You've really got to look at how data is grouped because it can affect your correlation.